Kenneth Rosen exercise 8.1 question number 10. Application of recurrence relation. Okay, this is interesting question. The question is saying that find the recurrence relation for number of bit strings that contain 0, 1. Containing 0, 1. Okay, you must contain 0, 1. So let's assume that what is Fn? Fn is number of bit strings of length n, containing 0, 1. Okay, you must contain 0, 1. So very simple. This is your Fn. Fn is number of bit strings of length n containing 0, 1. We must contain 0, 1. Okay, so first you find the initial conditions. First you tell me what will be F1. Can you contain 0, 1? If you have only one length, can you contain 0, 1? You cannot contain 0, 1. You cannot contain 0, 1. If you have two length, then containing 0, 1, how many you can create? Containing 0, 1, only one you can create. Only one you can create. Okay, what will be F3? F3 is like this. See, F3 is like this. Containing 0, 1. If you want to contain 0, 1, tell me simple point I'm asking. Simple point. If I put 0, 1 here, can I say anything I can put here? If I put 0, 1 here, my task is done. What I wanted to do, that is over. My task is over. What I want to do, that is over. I want to contain 0, 1. Already there is 0, 1. My task is over. So I can put anything here. I can put anything here. So there are two ways. Okay, or what I can do, if I put 0, 1 here, then what I can do, I can put anything here. Then I can put anything here. So F3 will be 4. Agree or not? F3 will be what? That will be 4. Is this point clear? Initial conditions, are they clear for this question? Now let's see. Now let's see the recurrence relation. So this recurrence relation is also very interesting. So you tell me, if you are I want to find number of bit strings of length n which contain 0, 1. My complete focus is on the 0, 1. What I want, tell me, I want 0, 1. Okay, I want 0, 1. My complete focus will be on 0, 1. I want this 0, 1. So tell me, what are the possibilities? The possibilities are these. I want to count this Fn, I want to count. So what are the possibilities? The possibilities are these: n length bit strings. Okay, or I can say, let's call them good strings. Containing, what are the good strings? Let me define. Please see. Let me define good string. What is good string? A string containing 0, 1. Okay, is this point clear? A string containing 0, 1. A string containing 0, 1. A string containing 0, 1, that is a good string. Okay, is this clear? A string containing 0, 1, that is a good string. So what is my task? Tell me, what is my task? A string containing 0, 1 is a good string. What is my task? My task is how many length n good strings are there. Okay, my task is count the number of length n good strings. Length n good strings. Okay, very simple. Good string means a string containing 0, 1. Now you completely focus on good strings. N length good strings. Just focus on n length good strings. Only focus on this. Okay, completely focus on n length good strings. This is what I want to count. I want to count n length good strings. These are the n length good strings. What are the possibilities? These good strings, I want to count these good strings. Now these good strings, either they can end with 1 or they can end with 0. Agree with me? Only two cases are possible. Do you agree? Only two cases are possible. Okay, I want n length good strings. I want good string means containing 0, 1. This is good string. So tell me, now there are only two cases possible. Either this good string will end with 1 or it will end with 0. Okay, so I will count these plus I will count these. This will be my answer. My answer will be, I will count these plus I will add these. Okay, so I can say these good strings, you can do like this. Either they will end with 0 or they will end with 1. Either they will end with 0 or they will end with 1. Okay, if you are ending with 0, then tell me, can it play any role in making a good string? If you are ending with 0, if you are ending with 0, can this 0 play any role in creating a good string? this 0, good string means you want to contain 0, 1. You want to contain 0, 1. You want to contain this 0, 1 substring. Contain 0, 1 substring. Now, a simple question I am asking. If you are ending with 0, can this 0 play any role in creating the good string? No, it cannot, because this is already at the end. This 0 is already at the end. This 0 is at the end. See, this 0 is at the end. So it cannot give you 0, 1. Can this 0, 1? Can this 0 give you 0, 1? Simple question. Can this 0 give you 0, 1? No, it cannot give you. So who will give you 0, 1? So it means here you must have a good string of length n minus 1. Agree with me? Here you must have good string of length n minus 1. Here you must have good string of length n minus 1. Agree? So far, is this point clear? So I am saying that if you end with 0, now this 0 cannot do anything. Okay, because you are ending with 0. So this 0 cannot give you 0, 1. This 0 cannot give you 0, 1. This 0 cannot play any role in giving you a good string. Okay, good string means a string containing 0, 1. So if the 0 cannot give you anything, then what you can do? From the remaining, in this remaining, you will search for good string of length n minus 1. In this remaining, good string of length n minus 1, that is nothing but f n minus 1, right? Okay, is this clear? Or what can happen? Or you can end with 1. Now tell me, if you are ending with 1, then what will happen? If you are ending with 1, can this 1 play any part? Simple question I am asking. Can this 1 play any part in giving you good string? Good string means containing 0, 1. So can this 1 play any role in giving you 0, 1? Yes, it can play. See, one more thing. If you are ending with 1, now, if you have 0 here, is my task over? Is my task over? If you have, see, you are ending with 1. Now, if you have 0 here, now can I go home? My task is done. I don't care about this. I already got 0, 1. 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 So my task is done. I don't care about this area. Do I care about this area? This area should be good or bad. This area should be good string or bad string. This area, just focus on this area. This area should be good string or bad string. This can be anything. This can be anything. I already got 0, 1. I already got 0, 1. I already got 0, 1. So this area can be anything. I don't care about this area. Here you can put anything you want. Here you can put anything you want. So if I'm putting anything I want, then there are 2 power n minus 2 ways. Okay, because every position has 2 ways. Every position has either I can put 0, 1, or I can put 0 or 1, 0 or 1, 0 or 1. Every position has 2 ways. So finally I can say 2 power n minus 2 ways. Now, but there is something interesting here. If I put 1 here and this symbol is also 1, now what to do? See what I'm saying. Now what to do? Now what to do? In this case, what to do? This case is pending. Okay, so now tell me, I want n length good string. I want n length good string. Good strings means containing 0, 1. I want n length good string. Good string means containing 0, 1. Okay, there is something interesting here. See, if I'm just focusing on this case because this case is pending. Agree? Can I say only this case is pending, right? This case is pending. This is the pending case. So in this case means when you have 1 here, you already have 1 here, and here also you have 1. Here also you have 1. Now what to do now? Anyone want to suggest what to do now? Can I simply say that, okay, a good string you find here? Can I simply say, just find the good string here? Can I simply say, find the good string here? Can I simply say that find the good string here? Is this simple? Can I say, find the good string here? Just find the good string here. Can I say that? What is wrong here? What is wrong here? Please tell me. Anyone? What is wrong here? See, this is wrong because this can play some role. Yes or no? You are putting it out of the equation. This one can play some role. Okay, are you getting my point? What is wrong here? This is wrong. I am saying that if this is 1, this is also 1. This case is pending. This case is pending when you are ending with 1 1. When you are ending with 1 1, this case is pending. This case is pending. Okay, now if you are ending with 1 1, can I simply say that here you must have good string? The answer is no. This is wrong. Why this is wrong? The focus, why this is wrong? This is wrong because if I have here something like this, okay, here I have something like this, and you are ending with 1 1. Okay, is it a good string? Is it a good string? Or in this area, just focus on this area. Just focus on this area. Is this a good string? No, this is not a good string. But overall, I am getting a good string or not? Notice. Overall, I am getting a good string or not? I got 0 1. So can I say here you must have good string? Can I say? Can I say, is this correct? That I must have good string here. I must have good string here. Is that enough? Or sorry, I can say I must have good string here. That is necessary. Is that necessary? No, that is not necessary, because this one can play some role. This one can play some role. Is this point clear? Please tell me. I hope this point is clear. See, I am saying that this case, when you are ending with 1 1, this case, when you are ending with 1 1, this case is pending. When you are ending with 1 1, I am saying that if you say that here you must have good string, means fn minus 2. If you say here you must have good string, what I will say? I will say this is not necessary. I will say this is not necessary, not necessary, because I can have this. I can put 0 0 0 0 0. Still I will get a good string. Still I will get a good string. See, look. Still I am getting a good string. So is this point clear that this is wrong? Is this point clear that this is wrong? Did you understand that this is wrong? Okay. Now, if this is wrong, then what is another idea? Yesterday, some students suggested in the private GoClasses private Telegram group, some students suggested that, sir, in this case, what you do, you simply count fn minus 1. In this case, you simply count fn minus 1. Means here you must have good. Here you must have good. Means here you must have good. Here you must have good. Here you must have good. Is this correct? Here you must have good. Is this correct? Is this correct? That here you must have good. Please tell me. Here you must have good. Is this correct? This is also wrong. This is also wrong. Why this is wrong? Why this is wrong? This is also wrong. Why this is wrong? Why this is wrong? Because notice, already there are 2 1s. Already there are 2 1s. See, please focus. This is also wrong, because the reason is this. It is not necessary, right? Okay, when you say that you have fn minus 1 in this area, when you say fn minus 1, please focus. When you say that this area has fn minus 1, this area has a good string of length n minus 1. When you say this area has good string of length n minus 1, are you considering this possibility? Are you considering this possibility in this area? In this area, are you counting this possibility? Please tell me. When you say that this area, focus on this area. When you say this area has good string of length n minus 1, then you are counting this, right? You are counting this. But that is not possible here, because already it is ending with 1. Is this point clear? See what I'm saying. Please notice. In this area, look at this area. In this area, if you say fn minus 1, if you say good string of length n minus 1, then you are considering this string. Right? You are considering this string, because this is also a good string of length n minus 1. This is also a good string of length n minus 1. So you are considering this string, but this string cannot go here, because you are ending with 1 1. Because this area is ending with 1. This area, just look at this area. This area is ending with 1. So, but you are counting this. So that is wrong. Did you understand this point, that this is also wrong? Because here you cannot have, but you are counting it. This string in this area, okay, in this area, this string you are counting, but this string cannot go in this area because this area is ending with 1. This area is ending with 1. I hope everything is clear. What is wrong? Did you understand? You cannot use fn minus 2. You cannot use fn minus 2. Similarly, you cannot use fn minus 1. So now you tell me, when you are ending with 1, so what should I do? If you are ending with 1, again very simple, it will go. See, if you are ending with 1, then there will be 2 cases. See, if you are ending with 1, if you are ending with 1, you are already ending with 1. You are already ending with 1. Okay, when you are ending with 1, there are 2 cases again. Again, here you can have 0 or here you can have 1. If you have 0, then tell me, if you have 0, how many ways? Now here you can put anything. Now here you can put 2 power n minus 3. And again, when you have 1 here, then again the same story will go. Agree with me? The same story will continue. Please tell me. The same story will continue. The same story is going to continue. Here you will have 2 power n minus 4. Here you will have 2 power n minus 4. And here you will have, again, here also, again, the same story will continue. Are you getting this point? Isn't this interesting? I hope you are understanding this question. See, I'm telling you, again, I'm telling you, you have Fn. What is Fn? This is n length good strings. Take your copy pen. This is n length good strings. Good strings means containing 0, 1. Good strings means containing 0, 1. Containing 0, 1. Okay, good string means containing 0, 1. Okay, so you want to count Fn, that is n length good string. Okay, good string means containing 0, 1. So what I can do? These are the possibilities. Okay, just focus on n length good string. This n length good string. Here you have 2 ways. If you are ending with 0, okay, just tell me this point. If you are ending with 0, then you are looking, then what you will do? Then this 0 cannot play any role. Agree? If you are ending with 0, can this 0 give you 0, 1? Can this 0 play any role in good string, in giving you good string? Tell me. Good string means containing 0, 1. Good string means containing 0, 1. Simple question I'm asking, that if you end with 0, can this 0 play any role in giving you good string? Can this 0, this ending with 0, can this 0 play any role in giving you 0, 1? In giving you 0, 1? No, it cannot play any role. There is no role. There is no role. And because there is no role, no role. So what you will do? You will search for good string here. Agree? You will search for good string here. You will search for good string here. Agree? You will search for good string here. That means Fn minus 1. Okay, very good. Very good. Or what you can do? You can end with 1. Or you can end with 1. Now, when you are ending with 1, or you can end with 1. If you are ending with 1, then 2 cases will be there. What are the 2 cases? If you are ending with 1, I am ending with 1. Now, there are 2 cases. I am already ending with 1. Now, there are 2 cases. If I put 0 here, then do I care what is here? I already got 0, 1. I already got 0, 1. I already got 0, 1. So here you can give me anything. Here you can give me anything. Whatever you want, you can give me anything here. Okay, give me anything. Means here you can put anything. Means here you can put anything. So that is the reason 2 power n minus 2. Okay, but if this second place is 1, if this second place is 1, can you notice you have come back to the same situation? Can you notice you have come back to the same situation? Okay, can you notice? Because this 1 can play some role. Agree? Can this 1 play some role to give you 0, 1? Can this 1 play some role to give you 0, 1? Yes, it can play. It can play some role. See, it can play some role. This 1 can play some role to give you 0, 1. So what I will do? Again, I got the same situation. I got the same situation. Again, what I will do? Again, I will do like this. I already have 1, 1. I already have 1, 1. Now I will consider if you have 0 here. If you have 0 here, then what you will get? You will get 2 power n minus 3. Okay, you will get 2 power n minus 3 because you already got 0, 1. You already got 0, 1. But if you have 1 here, then again what will happen? Then again the same. Then the same story will continue. If you have 1, 1, then the same story will continue. The same story will continue. If you have 0 here, then you can put 2 power n minus 4. And if you have 1 here, then again same story will continue. Again same story will continue. Did you understand? Did you understand? So what I got? I got Fn equal to what? I got Fn equal to Fn minus 1. I got Fn equal to Fn minus 1 plus a series I am getting. Did you notice a series I am getting? 2 power n minus 2, 2 power n minus 3, 2 power n minus 4, and so on. A series I am getting 2 power n minus 2, 2 power n minus 3, 2 power n minus 4. Till when I will get this series? This series, when this series will end? Okay, when this will end means you are going like this. Whenever you have this 1, 1, 1, see this is happening. Whenever you have this 1, 1, 1, whenever you have this, for example, if you have 4, 1, if you have 4, 1, then again you are going like this. Then again you are going like this. You already have 1, 1. You already have 4, 1, 1. And if you have 0 here, then you can put anything here. So you will get 2 power n minus 5. Okay. But if you have 1 here, if you have 1 here, already 4 1s are there. If you have another 1 here, if you have another 1 here, if you have another 1 here, then again you will go. Then again you will go. Okay. Then again you will go. Here you will get 2 n minus 6. But then again you will go. From here again you will go. Then you will get 2 n power n minus 7. But then here again you will go. When you will stop? When this branch will stop? Tell me. You are going like this, but ultimately when this, okay, you are going like this means 2 power n minus 7, 2 power n minus 7, and you are going like this. But when this branch will stop? Tell me. This branch will stop when ultimately you get all ones. Ultimately, because you cannot get all ones because you want a good string. This branch will stop when you get all ones. When you get all ones, and in this position only one position is there. Only one position is there, and in that position you put 0. Okay, are you getting my point? This branch will stop when you have all ones. Only one position is remaining. Only first position remaining. First position. This is the first position. This is the first position. In this situation, you will stop and you will simply say that 0 must come. In this situation, you will stop and you will say that yes, 0 must come. All the remaining are ones. Okay, and there will be nothing here. There will be nothing here. There will be nothing here. Please tell me, did you understand? So ultimately, you will stop at 1. There is only one way. Okay, so this recursion will stop at 1. This will just keep going like this, or I can say, okay, you are decreasing. Ultimately, you will go till 2 power 0. Please tell me, did you understand this question? Anyone here who understood this question? What is happening here? I told you everything. See, I told you what was the mistake. I told you that if you do this, what is the mistake? See, I told you Fn equal to Fn minus 1 plus Fn minus 2. I told you there is a mistake here. See, if you remember, please remember what I told you. What did I tell you? I told you that this is wrong. I told you this is wrong. And why this is wrong, I told you. Agree? See, this is wrong. And why this is wrong, I told you. Why this is wrong, we have seen. We have seen why this is wrong. Yes or no? Is this point clear? Similarly, I told you this is also wrong. Fn minus 1 plus 2 power n minus 2 plus Fn minus 1. I told you this is also wrong. Agree? This is also wrong. This is also wrong. I told you why this is wrong. we have seen. We have seen. So ultimately, what is correct then? Ultimately, what is correct then? Ultimately, this is correct. Fn minus 1 plus a series you will get. You will get a series 2 power n minus 2 plus 2 power n minus 3 decreasing, 2 power n minus 4 decreasing, decreasing to power 0. Okay, is this point clear? This is correct. This is correct. This series you are getting, and this is correct. Please tell me, did you understand? Did you find this question very interesting question? In the GATE exam, this question can come. Already in the GATE exam, there are 5 questions on recurrence relations. In the GATE exam, we have seen all the GATE exam questions, right? In our recurrence relation playlist on the GoClasses YouTube channel, we have seen all the GATE exam questions. You can see in the GATE exam, they are asking this type of questions. In the GATE exam, they can ask you this type of question. Writing recurrence relation. There are 5 questions in the GATE exam. They can ask you this type of question. Did you find this question something interesting, something new? Something new is happening. Okay, and remember the complete analysis I am telling you. I am telling you why this is wrong. I told you why this is wrong. And I also told you why this is wrong. Why this is wrong. Ultimately, the correct answer is this. So what is the final answer? If you see this series, what is the series? 2 power 0 plus 2 power 1 plus 2 power 2, 2 power n minus 2. What is this? This is GP. This is what? This is your GP. How many terms? GP with how many terms are there? 0 to n minus 2. How many terms are there? There are total n minus 1 terms. Okay. How many terms are there? Total n minus 1 terms are there. So tell me, what is the summation? The summation is first term multiplied by common ratio power number of terms minus 1 divided by common ratio minus 1. So that is 2 power n minus 1 minus 1. So your final answer will be what? Tell me your final answer. That will be fn minus 1 plus. That will be fn minus 1 plus 2 power n minus 1 minus 1. This is the final answer. This is the final answer. Tell me, understood? Did you understand this? Please tell me a simple point. Did you understand this? This analysis, did you understand? Let me know. Please tell me. Did you understand this analysis? So this is your final answer that we got. Okay, initial condition we have already seen. This is the recurrence relation that we will get. And this, what is this? This is the number of n length bit strings, n length bit strings containing 0, 1. Containing 0, 1. Okay, so this is the analysis. This is the complete analysis of this question. I hope you understood. Very simple, but very interesting. Okay, the most interesting part is actually finding the mistake. Why this is wrong? Finding the mistake. Similarly, why this is wrong? Finding the mistake. Finding the mistake is also very interesting. Okay, so anyway, this is the complete analysis of this question. I hope you understood. Find the recurrence relation. So your answer will be fn is equal to fn minus 1 plus 2 power n minus 1 minus 1. This is your final answer. Okay.